Lewis dot diagram. What is a Lewis dot diagram? Lewis structures are also known as electron dot structures. The diagrams are named for Gilbert and Lewis, who described them in his 1916 article entitled The Atom and the Molecule. Lewis structures depict the bonds between atoms of a molecule as well as any unbonded electron pairs. Atoms are written using their element symbols taken from the periodic table. Lines are drawn between atoms to indicate chemical bonds. Single lines are single bonds. Double lines are double bonds. Triple lines are triple bonds. Dots are drawn next to atoms to show unbonded electrons. A pair of dots is a pair of excess electrons. The steps to do a Lewis dot diagram. First, pick a central atom. Start your structure by picking a central atom and writing its element symbol. This atom will be the one with the lowest electronegativity. In our example, carbon dioxide, if you check in the periodic table, carbon is at the left of oxygen, making it to be less electronegativity. So as a consequence, it goes in the middle. Electronegativity typically increases as you move from left to right across the periodic table and decreases as you move down the table from top to bottom. Once you have selected the central atom, write it down and connect the other atoms to it with a single bond. You may change these bonds to become double or triple bonds as you progress. Step 2. Count electrons. Lewis electron dot structures show the valence electrons for each atom. You don't need to worry about the total number of electrons, only those in the outer shells. The octet rule states that atoms with 8 electrons in their outer shell are stable. This rule applies well up to period 4, when it takes 18 to fill the outer orbitals. 32 electrons are required to fill the outer orbitals of electrons from period 6 and on. However, most of the time you're asked to draw a Lewis structure, you can stick to the octet rule. Third, place electrons around atoms. Once you have determined how many electrons to draw around each atom, start placing them on the structure. Start by placing one pair of dots for each pair of valence electrons. Once the lone pairs are placed, you may find some atoms, particularly the central atom, don't have a complete octet of electrons. This indicates there are double or possibly triple bonds. Remember, it takes a pair of electrons to form a bond. Once the electrons have been placed, in some cases you need to add brackets around the entire structure. If there is a change of charge on the molecule, write it as a superscript on the upper right, outside the bracket. Now let's have fun and practice. Our molecule, carbon tetrafluoride. First step. Pick a central atom according to its electronegativity, the one with the lowest electronegativity in the middle, in our case, carbon. Second, count valence electrons and add them in an electron dot diagram. 7 for fluorine, 4 for carbon. Step 3. Place electrons around atoms. Remember, a dash between two elements takes out one electron from each one. So we'll have the same structure, and the electrons from carbon are already being used in the dashes, and one electron from each fluorine. So in each fluorine we'll have 6 electrons left, which are lone pair of electrons. And that's our done Lewis dot diagram. Here comes another one, in this case an ionic compound, sodium bromide. Pick a central atom according to electronegativity. In this case there is no central atom as we have only two atoms. So they are arranged from lowest to highest electronegativity. Remember, in an ionic compound, always is formed by a metal and a non-metal. In our case, always the metals will have a lower electronegativity than bromine. So sodium at the left, bromine at the right. Step 2. Count valence electrons and add them in electron dots diagrams. For bromide, that will be 7, and for sodium, 1. Third, place electrons around atoms. Remember, if we have charges, we need to add brackets around the most electronegative element, in this case, non-metal. So let's place bromide with the 7 electrons, sodium that gives out his electron to bromide to complete his octet. Then each one of them will have a charge. We need the brackets to indicate this. Negative charge for bromide and positive charge for sodium, as is the giver. And this is our Lewis dot diagram. Let's do the last one. Our molecule, ammonia or nitrogen trihydride. The first one, pick a central atom according to its electronegativity. The one with the lowest electronegativity in the middle. Back again, nitrogen in the middle, hydrogen around it. Second, count valence electrons and add them in an electron dot diagram. 5 for nitrogen, 1 for hydrogen. Third, place electrons around atoms. Remember, a dash between two elements takes out 1 electron from each one. So from the previous structure, we can see the hydrogens are already complete because they have shared 1 electron and 1 electron from nitrogen. And nitrogen is using 3 of them, and obviously it has 2 more, and that will be a lone pair of electrons, and that's finally the Lewis dot diagram. Thank you for watching.